Great, let's get started. Conan, welcome back for the third discussion we're having.
Thanks, Phil.
So I've been looking forward to this conversation because it's really something that is quite close to our hearts here at DigitalGenius, which is conversational AI. And we'll be talking about some of the evolution of this particular technology, some of the challenges, but also some of the opportunities that might be possible as the technology advances. And what I think is really interesting about this specific topic is that actually we've seen a lot of progress in other areas of AI, but in conversational AI, it feels like it's still catching up in some ways. And it's funny because there's expectancy in the way that we see the technology and how we want to interact with it. So Conan will talk to you a bit more about that. We won't skip ahead to the good bits just yet. And sort of like all of our conversations, we're going to start off just by defining, what this technology is and what it's not, what it's capable of today. Talk about some of the underlying challenges. In the second part of the conversation, why is this difficult, both from a sort of almost biological point of view, but then also machine learning point of view. And then we want to talk a little bit about some case studies in the real world today. And we'll talk both about voice case studies and also text-based case studies. And then as we do with every one of these conversations, we're going to talk a little about what's coming next, what's on the cutting edge, and what might be the inputs that take this kind of technology forward. So this can be a fun one. So Conan, why don't we get started with just a bit of an introduction, a bit of a definition on conversational AI. What is this exactly?
Yeah, definitely. So conversational AI is just any computer software that simulates the interface of natural language to solve problems for users. Okay. Those problems might be quite simple, switching on your lights in your house or your music, or they might be more complex. They might be trying to help you to work through personal problems, for instance, like a therapist might, or something like that. So, but generally speaking, it's some software that is solving problems with a natural language interface.
Okay, got it. So that's the component through which you would solve whatever the problem is through language, effectively.
Exactly. So conversational AI is definitely not necessarily artificial general intelligence. We have a tendency to conflate the two because natural language is such a basic feature of human life, of the way we, the way that we sort of define what it means to be human, that we aren't, so used to the idea of a computer interfacing with as a natural language. With conversational AI, you might be solving a narrow set of problems compared to those that a human might be able to solve with natural language. And by doing that, you can do it with artificial intelligence that is far from capable of the kinds of things that people are capable of, so long as the thing just trying to solve are quite simple.
Got it. Okay, so there's kind of an expectation gap in a way, that if you think that you can sort of talk to a machine, that the machine is actually going to respond to all of your queries. Okay, that's interesting. And what's actually the types of AI that's powering these interfaces?
Yeah, so there's technologies from natural language processing are almost synonymous, and with conversational AI being one application of them. And natural language processing, you could, from one point of view, split it into three sort of subcategories of work.
Got it.
Those would be, to use language, what do we need to use language? We need to, you could say that we need to understand it. When language arrives at us, we need to be able to interpret it, to sort of frame it in a way that we understand.
Sure. Yeah.
We need to be able to reason with it. So we need to attach it to memories and other bits of information that we might already have stored in memory. We need to compartmentalize it and break it up into its,
component parts, right? Yeah,
component parts, yeah. And we need to reason with it that way.
Got it.
To derive meaning from it.
Right.
And finally, we need to be able to generate language, right? So we need to be able to create new language to respond, to have a complete interface where we can respond to the communicator that is speaking with us.
Okay. Yeah.
So there you have natural language understanding, natural language reasoning, and natural language generation. Right. Those are three areas in natural language processing. A machine that is capable of representing a natural language, arriving at it. A machine that's capable of reasoning with that language to extract new facts or to merge it into facts that it already has, and then that is capable of creating new natural language to respond to in a way that you can understand.
Got it. Okay. So it's almost like it's kind of like mimicking the the logical and responsive like train of a conversation or an interaction in the same way that a human being would do so. So that's kind of interesting. We saw that in our last conversation about machine learning, and we talked about neural networks, how that's sort of mimicking the way that neurons kind of operate in the brain. With these natural language techniques, it seems like there's a bit of mimicry there in terms of how a human would engage with data they're getting and how they would respond to it. But okay, so if we've got these three areas: natural language understanding, natural language reasoning, and natural language generation. Have I got it right that we've done a pretty good job on the understanding part of things? Reasoning is maybe mixed, and then generation we're still some ways away from fully cracking.
Yeah. So yeah, that's pretty much right. Yeah. So a machine can generally, using neural networks, contemporary techniques, we can generally represent language quite accurately and map it onto simple concepts. So the topic of sentences, whether sentences in a news article or about religion or politics or sport. So that's something we've become quite good at. Reasoning is a harder task. Simple reasoning we've achieved to be able to identify the sort of the category of pieces of information in your language. So if you mention your date of birth or you mention your age, then to be able to take that out as a variable data point and be able to use that information for something else. And generation this is the hard problem. That in the last, we'll speak about it later a bit, I think, but just in the last few months, there's been quite a lot of progress there.
Yeah. Okay, got it. Okay, so I hope that's a good introduction into kind of what conversational AI is and what are some of the component pieces that form this technology. We've kind of established that there's a bit of a mixed bag in terms of the capabilities today. We need to double click a little bit on why that is. Why is it that AI is quite performant when it comes to things like translation or image recognition, even things like image generation, and we talked about this for these general adversarial networks last time. We can even generate new images, right? That's really cool stuff. Why is it that there seems to be a bit of a lag, on the conversational AI stuff? Let's maybe talk about that.
Yeah, there's a couple of reasons for that. So one good sort of rule of thumb with machine learning technology at the stage it's at just now is that anything that a person can do instinctively, intuitively, on the spot, probably machine learning can do that now.
Okay.
Right? So a bilingual person, with translation in the example you mentioned, the bilingual person, when they're prompted to translate a sentence from one of their languages to another, the language just appears naturally for them, right? I mean, then they might rework things later, but just the translation just appears intuitively for them. Similarly with things like facial recognition, with simple reasoning tasks, sort of like very quickly trying to identify someone's age group, roughly, these kinds of things. So how, with language processing, however, that's not really how we work. We don't intuitively, complex language tasks are not something where the answer arrives intuitively. If someone arrives at you asking you to solve a problem with their computer, this is something that requires investigation, it requires information gathering, it requires a process of reasoning and analyzing to emerge for solutions to the problem to emerge.
Okay. So
this is one of the reasons. The other reason is just that language is innately a very complex thing, and we take it for granted.
Yeah.
We just think that it's because it comes naturally to us. It's something that the complexity underlying there is something we don't quite always think about.
Yeah.
But every single word that you use when you are communicating with language, you're making a sequence of decisions in a space. Your choices are tens of thousands of ways that you could take that decision. That's how big your decision space is. And you're instinctively making those decisions all the time. It's not easy to get that sort of decision-making acuity in a natural language processing.
And we're sort of all we've learned the kind of stock of available words. We've all learned that they're stored somewhere in our head. It's not like we're looking, for them in a dictionary before we can start using them. We're plucking them out somewhere in the recesses of our mind and then formulating them in hopefully what is a logical sentence. But yeah, okay, so there's a lot of complexity there. And I guess that almost brings us back to kind of like an evolutionary point, right? I think you mentioned we take it for granted. It seems like, and this has been talked about by many, and I'm sure if anyone's read *Sapiens*, this features heavily, but our ability to communicate with one another is one of the critical factors in the success of the human race. As what we've got to today, it's that communication between members of a tribe, which is not so straightforward when you really think about it.
Absolutely. I mean, there's a strong drive to natural language, and evolutionary forces to sort of push towards increasingly complex natural language. We're starting to understand even in other species that there are more complex languages that they use that we weren't aware of in the past. But with humans necessarily, we have sort of a if you compare us to other closely related ape species and so on, we have sort of evolved as a specifically language, a species with strong language expertise that we probably for now haven't found anywhere else. So there is that side to it as well, and it is and even so, the time, the billions of years that it took, even with those strong natural forces pushing life towards language, the complexity of the task maybe has meant that only until several thousand years ago or tens of thousands of years ago this was actually possible. So.
Right, got it. Okay, very interesting. So there's a real complexity then in the way that our own brains work, and then how we actually interact with how we interface with language, and replicating this in an artificial manner is clearly quite challenging. So you talked about narrowness a little bit earlier in the introduction. I think that's probably a nice segue into our case studies. So how are these current applications of natural language AI and conversational AI, how are they kind of getting around and providing somewhat viable solutions in the market? What's the approach there?
Yeah, so we're talking about the complexity of our decision space and when we use language, and that is a difficult problem to solve. But we have realized that in the context specifically of software, you often don't need to solve just general human problems. Depending on the nature of what you're trying to do, the number of problems you need a solution for can actually be very narrow. So if you just bring the breadth of, I guess, attention, what your system is going to achieve, down to the few basic things that if you do that, your system is sort of pretty good functioning product, and you can do that. If you look at, you mentioned use cases here. So the home assistants that we use at home these days, there must be maybe 40, 50, 60 problems that they solve for people at home. Google's Home Assistant will, we mentioned earlier, switch your music on, turn your lights on, check the weather, read the news. There can be more than maybe 4 or 5 dozen problems that's solving for you there, and that's achievable. That's something you can do today. Similarly, with the software we develop here, our customers usually have 4 or 5 problems that they want to solve in their customer service volume that knocks out a huge percentage of what's happening in their environment. So in those cases too, we find this. So by narrowing down what you expect your product to accomplish, then you can get a lot done.
Got it. Okay. So that's a very good segue into the kind of case studies we're going to talk about, which are, you pointed out, these home assistants, and then also chatbots, and which are pretty commonly used almost everywhere now. Are there any ways in which these two interfaces are different? Obviously, one is voice, one is text-based. Is there anything noteworthy there?
Yeah. So think the home assistants in general, the sequence of things they need to do is quite simple. The big bulk of the success of the technology is in the natural language understanding from human voice, because it's a lot harder to correctly interpret or understand what people are saying than to understand what they're writing.
Sure, yeah.
Yeah, so
there's variation in accents and syntax and so on, whereas written format is much more straightforward.
Volume, tone, all those things.
Yeah.
On the other hand, with chatbots, what you have is the interface between the natural language and the software is somewhat easier via text, but then usually the sequence of decisions can be much longer, right?
Right.
Yeah.
Right.
So if you think of a medical diagnosis tool, for instance, that uses a chatbot to talk people through how they're feeling to try to find the diagnosis. You know, the questions a doctor asks you to do that, you might have 10, 20, 30 questions. There might be physical checks, there might be other things. So the sequence of decisions you need to successfully navigate with a chatbot is usually a lot harder. Right. So that's kind of the difference there.
Yeah, and that illustrates sort of the use cases of why you use one or the other, right? Because as an individual user, you know, I would ask Google, you know, on their kind of a voice search functionality, you know, what's the weather like today, or is my train on time? Because I just want one single answer back, but I wouldn't necessarily want to use a chatbot for that, and vice versa. When I need to find out the answer to something that's a bit more complex, or I need to provide information, you know, voice today doesn't seem like a very good or able method of doing that.
Absolutely, yeah. And like, I think that's also related to the market fit of the company and what they're, you know, what the market fit of the product they're developing, right?
Right.
So with Google being fundamentally a search company, right? Just the need for a home assistant in search or a voice assistant in search is it just slots in perfectly for them, right? You want to get information through your keypad, but you also sometimes want to get information when you're in your car, when you're traveling, when you are, you know, feeling handy to type out your queries and so on. So then on the other hand, some companies like Amazon, which are Amazon's a retail company, so they work with Alexa, they need to find some fit for that product into retail, which is also why they're looking at IoT and this is kind of, you know, filling up your fridge for you and that kind of stuff.
Buy more of whatever that you have in your fridge. Yeah, got it.
So there's a bit of it. So it's harder for them to find that market fit with their Alexa products.
So there's the data lag, and then there's also, not only the data lag, just because Google just has so much more search data, but then also, you know, think about an application. You know, Amazon's got in the grand scheme of things, a relatively narrow application, which is in retail, whereas Google can cover so much in someone's daily life.
Exactly.
Okay, so the use case is obviously pretty critically and important, and I think that's a lesson that we've seen over and over again with chatbots. It's looking at what is the use case that the chatbot is trying to solve, and making sure that's narrow enough and supported by sufficient data to make it effective.
Exactly. Yeah.
Got it. Okay, so that's sort of, I guess, two kind of case studies that we're looking at, and as you said, kind of just to underline this part of the conversation, the fundamental areas of success are in this ability to narrow the use cases, to find, you know, the 5 to 10 or the 15 to 20 things that solve 90% of the problems or 85% of the problems, that make it viable enough, and to build these natural language models to serve, you know, those core problems. But then that last 10-15% is just right now too complicated.
Exactly.
Okay, got it. So that's actually, again, a nice segue into our final section, which is kind of talking about what's coming next, and I guess what are the things that could expand the narrowness of the applications today. So we've got a bit of a theme so far in this conversation, which is thinking about understanding, reasoning, and generation. So kind of sticking to that, where are the breakthroughs you think we can see in those three areas?
Yeah, so in as far as natural language understanding goes, the places where we are sort of still working on better solutions are mainly in context in which the language appears. So it's one thing to receive someone's message via text. It's another thing entirely to have a broad range of context about who the person is, about the kind of day they've had, the nature of the relationship, you know, the type of problem they're solving, possibly whether they've, whether the problem has a history, right? This is just in the case of text, also obviously in the case of voice or video. There's all kind of contextual clues that come along with people's language, their facial expression,
right?
Their location, the tone of their voice, and again the history of the relationship, and so on. So I think in understanding, we're going to see a lot of work going into enriching the context that natural language systems have to then later reason with the language that is arriving from the user.
Right. Interesting. Okay, so those are so many different use cases there you can think about. But if you're Google and you've got my location data, and you've seen that I've been home late than I usually am. Google can then cross-check that with the weather, and it turns out that it was raining that day. So all these different variables and inputs, but I guess also the bits on kind of posture, body language, and tonality are kind of a separate problem that you need to input, and how those things are weighed. Fascinating. Okay. And I guess also presents some interesting challenges around data and privacy and all that, but that's another conversation that we're not going to have here. Okay, great. So that's understanding. What about reasoning?
So with reasoning, I mean, just what we have now is just relatively basic, right? It's just simply not very good, right? We have ways to extract entities from language, right? That's a way of reasoning with language.
Sure.
Provide some information to me, then I can take your attributes from there. This is an email address. This is Phil's email address. This is his age. This is his username, and so on. These kinds of things. Or extract historical facts from an article, that kind of stuff. But reasoning also involves a process of information gathering. When you're prompted with a piece of language, you start associating it with information that you might already have gathered in the past, or that you then go out and try to find in the world, right?
Got it. Okay. So more sophisticated relationship with either previously accrued data, but then also more sophisticated relationship with what other contextual clues are out there. So it's using that. If we go back to understanding, it's using that extra data that you can infer from either the person's data profile or the body language. But then it's the sophistication to do something with that and then make a judgment against it.
Exactly. That's exactly right. Okay. So in reasoning, we're going to see a lot of work there, and then natural language generation, which is this is the process of creating new language.
Right.
Once you've reasoned and you have your solution, of creating new language to express the solution to the user. That's what we're going to see a lot of work there. If we'd done this webinar 6 months ago, I would have told you not very much is happening. Natural language generation is still very poor, and it's very difficult to get right. Some of the listeners might have seen recently, just in the last month or so, OpenAI. There was a bit of a news piece about OpenAI software, which is actually creating very realistic generated content. So it just generated articles about sport and politics and so on. Generations, some fake social media comments, things like that. That really, for all intents and purposes, sound very convincing. But what people should know is that they're totally arbitrary. Basically, the way to think of how those systems are working is, if I asked Phil to speak about last night's Champions League football match. And Phil hadn't watched it and had read nothing about it, but he's seen some football before, so he just started spouting random stuff that looks like an analysis of the game, right? So you compare those to the factual world, and there's nothing there because there's no reasoning behind it, right? And that's why those three pieces all need to come together, right? Understanding, the reasoning, and the generation. So this comes to maybe a fourth point, that what will happen a lot is that these three components of natural language processing, we're going to start learning how to make them work together much better, right? Until now, a lot of the research does somewhat treat them as separate things to be worked on individually. In particular with reasoning and generation, when we start learning how to get those things to better play together with each other, we're going to see a lot of really cool results in the future.
Okay, interesting. That's very cool. I think, OpenAI, for those who don't know, I think it's an Elon Musk-backed company. They actually retired they declined to release the research for fear of what it might unleash. That could be some Elon Musk anti-AI propaganda, but either way, it's a good story. One of the, I'm just thinking about the benefits of natural language generation. I mean, to me, it sounds really cool, but actually beyond it being a fascinating accomplishment, what actually benefit does it serve if I'm interfacing with a natural language or conversational AI interface?
Yeah. So just now, a lot of conversational software is actually pulling out pre-written and canned pieces of language.
Okay.
Yeah. So the system identifies what it wants to do, right? From, as we were saying earlier, this narrow set of 50, 60 or fewer problems, right? Solutions. And it picks out a pre-written piece of language to address the user with that, right? So two people with the same problem will always receive the same response, right? You might try to do something a little bit smarter, like have little variations on it, but that's the best you can do.
Yeah.
Right? If we can, get to a point where natural language generation can work much better with other parts of those software components, right? Then we can have completely customized responses to two people who have the same problem, but who might be coming at it from a different context.
Right.
Right.
I understand.
So two people might want to renew their contract, but one of those customers might be very upset. One of them might be fairly happy with the service they've received. And with good natural language generation, you can notice that, and you can have a response that's better tailored to the experience of the user.
And that's, as you said, that's a really good example of those three kind of algorithm areas working together, because if you can suddenly collect information about the user that's outside of the conversation, getting data about their service history, about the number of incidents they've reported, and start to build analytics around that, and then obviously infer that those collection of data is actually more likely for an unhappy customer might churn, and then generate the language on the back of that that's going to make for a more personalized experience.
Exactly.
Okay, fascinating. Any other parting thoughts before we sign off?
Well, just to summarize the way probably things will play out here is we have these systems now that over the last decades have evolved from requiring a lot of human work and being extremely narrow, and machine learning wasn't so good, to, as the machine learning got easier and we could learn from data and we could put down a lot of that engineering cost to figuring out very specific things about very specific problems. Then we can start broadening the problems that software can solve with us with natural language. And we'll probably see that continuing with the advancements that we've just been talking about. So it's, the ability of the software to explore its environment, to find new information increases, and we get better and better at that. It'll just be easier and easier to start tacking on new and more complicated problems to that breadth. And at that point, I say that's how we move towards what you might call artificial general intelligence.
Right. Got it. So I'd say it's a real transformation, potential transformation of a lot of the work that's going on today, and the nature of work, and also our more importantly, I think our relationship to machines, which is a fascinating topic. Again, another separate one to this conversation. But how are we going to interface with machines, rely on them, for emotional support, for who knows what, but language, as you said earlier, is a real gateway to forming bonds and relationships. And once a machine can start to build that trust, build that bond with you, then that's going to create some interesting side effects that we probably can't anticipate.
It's definitely going to be interesting.
Yeah, sounds good. Conan, thanks again for the conversation. Another good one as always. And thank you for joining us today. As always, any questions, please do get in touch with us on either of our sort of social channels on LinkedIn and Twitter, or you can email us at hello@digitalgenius.com, and hope to see you again next time. Thank you.